Absolute values are a topic that are oft neglected in the classroom, and I want to change that. Welcome to RE Tutors Math. In this video, I want to talk about what is an absolute value, how do you graph it, and how do you think about it conceptually. First question, what is an absolute value? The way I explain it to my students is that an absolute value is just a distance. It's the distance from a zero. Hey everyone, editing Ari here. I just wanted to explain what my game plan is in this video. I'm going to show you two really quick examples of basic absolute value problems, and I'm going to drill home the idea of thinking about an absolute value as a distance. And then I'm going to talk about graphing, and I'm going to show you a basic absolute value graph, y equals absolute value of x, and then three different types of transformations that could happen with the graph. And then I'm going to culminate it in one final awesome example where we do all three transformations at the same time. That's basically like the hardest absolute value type of graph you'll ever be asked to do in an algebra class. Yeah, it's going to be pretty awesome, so stay tuned. So if we jump onto the whiteboard, a lot of us know like the absolute value of -5, we know that it's equal to 5. Why is that? Because the distance of a -5 from 0, how far away is it on the number line? -5. It's 5 away from 0. Intuitively, that's already giving us the reason why absolute values are always going to be positive. You can't have a negative distance. Even if something is to the left, it's still a certain distance away that is positive. So the absolute value of a number like -5 is going to be positive 5. It's 5 away from 0. Okay, let's do another one. Let's get rid of that. Another one. Okay, let's say we have the absolute value of x minus 2 equals 3. Here's how I would read this as a sentence. The distance from 0 of x minus 2 is 3. Let me say that again. X minus 2 is 3 away from 0. Okay, so this means x minus 2 is 3 away from 0. That's how I would read this. Now, what is 3 away from 0? Here's 0. So if we go 3 to the right, we're at 3. If we go 3 to the left, we're at -3, right? So that means that x minus 2 could either equal 3 or x minus 2 equals -3. So if your teacher told you, like, when you have an absolute value, you have to do the plus case and the minus case, this is what they're talking about, and this is why. Because it's describing a distance from 0 that could either be to the right or to the left. So obviously we could solve this pretty quickly. Here we have x equals 5, and here we have x equals -1. So those are your two solutions. Okay, topic number 2, I want to talk about how you graph absolute value functions. So the graph of y equals the absolute value of x is going to look like a V. Just like this. When we have, like, let's just talk about a few points on this graph real quick to kind of explain this result. If we have x equals 5, well then y is going to equal 5 because the absolute value of 5 is 5. So we're going to have a point right over here at 5, 5. Well, what if x is -5? What if x is -5? Y is going to be 5 because the distance from 0 of -5, it's 5 away from 0. So that's why we have a point right here at -5, 5. So it's going to be this perfect symmetrical V. And the slope is going to be 1 over here and -1 over here. You can see that it's just like going down and then it's going up. And this point right in the middle, this point right in the middle at the origin is what we call the vertex, like this. So our vertex is at 0, 0, and that's going to be important because when we transform this function into more complicated examples, that's going to shift around. So let's talk about how we could transform this function and like how to graph more complicated absolute value functions. So if we have, for example, y equals the absolute value of x minus 3, what is that minus 3 going to do? So we already know that absolute value of x is this v, right? That's y equals absolute value of x. So now in blue, let's say y equals absolute value of x, and then the minus 3 is going to be outside the absolute value. What is that doing? It's going to take every single point on the graph and bring it down 3. So whatever this point is here, it's going to shift down to here. This point right here is going to shift down to here. This point right here, shifting down. So we're going to end up with this v that's all shifted down 3. We're going to have a negative 3 right here. The vertex, our new center point, is going to be down at negative 3, at 0, negative 3. I hope that makes sense. It's kind of like a y-intercept. You could think of it like that, where that number that's being added or subtracted from the x is going to shift things up or down along the y-intercept. So that's what a number out here does. Obviously, if we had absolute value of x plus 5, absolute value of x plus 5 out here, not in the absolute value, then it would shift up 5, just like that. Okay, so now let's look at a different example. Our second function transformation, which will be y equals absolute value of x plus 2. So what if the number that we're adding is inside the absolute value? So in this case, instead of shifting it up or down, this is going to shift it left or right. When the number is outside the absolute value, it's shifting up and down. When it's inside, it's shifting left and right. And intuitively, you might think that plus 2 means that we're going to the right 2, but it's actually the opposite. When we have a plus 2 in here, it's going to shift to the left by 2. So now instead of having our vertex here at 0, 0, we're going to have it at negative 2, 0. And our graph will look just like that. Now, if you want to understand why it's shifting to the left, my recommendation would be to just plug in a bunch of x values, and you'll see what the y outputs are, and you'll kind of understand how this graph takes its form. But I don't really want to spend too much time talking about that in this video. I just want to do 2 more quick examples, and then we will wrap up. So the next one we will do is y equals 3 times the absolute value of x. And you could think of this 3 kind of like a slope. So previously we haven't had coefficients in any of our functions. So the implied coefficient, sort of like the automatic coefficient, is 1, because multiplying by 1 doesn't do anything. So what I mean by that is y equals absolute value of x is the same as 1 times the absolute value of x. So you could think of 1 as our previous coefficient, which is why we had this slope of negative 1 and then a slope of positive 1. So now that we have a 3, all it's going to do is make our slope negative 3 and then positive 3. So this number out here is going to affect our slope. So to recap what we've learned so far, let's say we have y equals a times absolute value of x minus b plus c. The c shifts it up and down, b shifts it left and right, and a affects the slope. All right, now I'm going to walk you through one last example where we incorporate all 3 of these elements at the same time. Okay, final example, and then I'll let you go. I promise. Okay, we have y equals negative 5 times the absolute value of x minus 2 plus 7. Let's kind of look at this from right to left. So again, to reiterate this point, any type of absolute value function is going to be a v-shape. The question is just going to be, where is that center point? Where is that vertex? And the other question is going to be, what is the slope? So center point is dictated by the 7 and the -2. The 7 tells us we're shifting up 7, and the -2, the -2 tells us we're shifting to the right by 2. All right, so we're up 7 to the right 2. That's our vertex. Now we have a slope of a -5. Now we know the slope it's really going to be two slopes because we're going to have a positive slope and a negative slope. It's going down then up. But here, since it's a negative number, we're flipping the v upside down. So everything, basically all the points are going to be flipped over. So instead of having this like positive graph like this, instead of that, we're going to have this. And our slope is going to be 5 and -5. Those are our slopes. So obviously this isn't like a super accurate graph, but that's the general idea of how you graph absolute value functions, how these different numbers will impact the graph, how they transform things. And yeah, I hope this gave you a good overview of how absolute value functions work. Remember to always think of absolute values as distances. I think that's where most people get tripped up. But if you just remember that absolute values are a distance, and you remember kind of where we started, which is this problem right here. X minus 2 is 3 away from 0. I think that's like the biggest conceptual change that a lot of students need and that I needed when I was learning about absolute values. So I hope you enjoyed this. If you did, like, comment, subscribe, and yeah, if you want private tutoring, you could email me at retutorsmath@gmail.com. Have an awesome day.